3. Today we'll be doing more solving of log equations. So our first equation right here says 2 log base 5 of x equals log base 5 of 9. So the property we're going to use first is going to be kind of a common sense property. If log base a of x is equal to log base a of y, our conclusion is that x must equal y. So the main thing to know is you're not really dividing a log because a log is a function. This is more of like a common sense kind of thing. Log of this equals log of this one. The two things must be equal. So let's apply it here. The first thing I want to do is hairball that 2. So let's grab it, move. Log base 5 of x squared is log base 5 of 9. Notice now I'm in that situation where I have log and a log, same base. So our conclusion is that x squared should equal 9. Now we're going to root it. Absolute value of x is equal to 3. So x must be 3 or negative 3. However, now that we have more advanced equations, put a big note here. You have to always check your answer. Now what I mean by that is, remember with logs, say log of a box. This box, has to be greater than 0. You can never have a negative in here. So this negative 3, if you put it back here, you can see that you can't do log base 5 of negative 3. You can't log a negative number. So you cross out negative 3. Your only answer is 3. Okay, let's try another harder one. Log base 5 of x plus 6 is, or plus, log base 5 x plus 2. So first, let's combine them. So recall that if you're adding logs, you'd multiply. So that would be x squared plus 8x plus 12. That's equal to 1. We should hopefully remember our basic log property. If you have something in log form, that's equivalent to a to the b is equal to x. So for this one, let's go 5 to the 1 is equal to x squared plus 8x plus 12. Let's keep going. 0 is equal to x squared plus 8x plus 7 once I minus 5. Let's factor. X plus 7, x plus 1. So x is equal to negative 7 or negative 1. Now we're going to check our answers. So negative 7, I can see if I plug it into either one of these, it makes the log negative. And you can't log a negative number, so I know negative 7 doesn't work. Cross that out. Plug in negative 1. If I plug negative 1 here, I get 5. If I plug in negative 1 here, I get 1. So negative 1 does check out. So we'll circle that, and we are good. So notice here that a negative answer, of course, is possible. It's when you plug it in, you can't log a negative number once you plug that number in. So make sure you make that note. The negative answers themselves are fine. It's when you plug it in, you have to check that they actually work. Let's try one more example here. This is another simple one. Now we have natural log. So the first thing I want to do is combine these two logs here, make it a little bit easier. Natural log x equals natural log x plus 6 over x minus 4. Now I'm in that situation where I have log of something equals log of something. The two things must be equal. So let's just keep going like that. We're going to multiply by x minus 4. So x squared minus 4x, that's equal to x plus 6. X squared minus 5x minus 6, that's equal to 0. Let's factor that. And there we go. 6 and negative 1. Again, don't forget, this whole unit you got to check. Plug in 6, that's okay. Plug in negative 1. Negative 1 right here is okay, but look right here and right here. That makes these two negative, so that's not okay. So cross out that one. 6 is your only answer. Okay, now for an advanced example. So this one, I need all of you to notice that as it is right now, we cannot simply add them together because look at the bases, right? These bases don't match. So if they don't match, there's not a lot you can do as far as the properties. So what we got to do is make them match. So I'm going to show you a kind of a secret thing today. Put a box right here. This is going to be a secret log property. So don't tell anybody. If you have log base A of B, that's equivalent to log base A to the n of B to the n. So notice how you just have to raise both of these to the exact same number, and it stays equivalent. Now you might be wondering, like, how could that be possible? Well, I'll show you. Let's say we have log base A to the n, B to the n. Let's do change of base. So log B to the n over log A to the n. Now move these over. That's n log B over n log A. The n's cancel, and that condensed would be log base A of B. So these two things must be equal. So that's how you can use this property, and it's very, very helpful when the bases don't match. So for this problem, it's pretty easy to fix it, right? I need 2 to go to 4, so I'm going to square both of those. Now look at the problem. It's trivial. Now the bases match, it's like everything else we've done today. Combine the left side, that's x squared minus 2x. Let's convert this to exponential form. 4 to the third equals x squared minus 2x. So 0 should equal x squared minus 2x minus 64. Now we want to factor that, but we definitely can't, which means we have to do the quadratic formula. So x equals opposite b plus or minus the square root of b squared, that's 4, minus 4, and that's going to be a is 1 and negative 64, all divided by 2. Now hopefully you guys know the trick to make this easier. We're going to factor the part of the radical right here, because I noticed there's a 4 in both of them. So I'm going to factor that out. So I'm going to put radical 4 here, and that would be 1 plus 64, all divided by 2. And look how much easier that is. That's just x equals 2 plus or minus 2 radical 65 over 2. Let's reduce it. That's going to be 1 plus or minus radical 65. Now in a question like this, you're going to get excited because you did all this work, you have your answer. You still got to check. So even though root 65 is not a nice number, you can approximate that. That's about 8. So this is about 9 and negative 7. So we can see the positive one, 9, that's going to be fine. But if I plug in negative 7, yeah, that's not going to work. So to make it easier, you can think of it like this. X equals 1 plus radical 65, and x equals 1 minus radical 65. Cross out that one, that's your negative answer. And there's your final answer.